Okay, so we're having problems with the video part. So, in order to read math, we have three numbers here. We have 3 to the square root of 12x cubed, square root of 20x cubed, and square root of 108x cubed. So, as I showed in my math before, we simplified 12 into 3 and 4. 4 is the perfect square of 2, so therefore 2 already goes on the side. 3 times 2 is 6. Since it's x cubed, there is 2x in there. So therefore we can bring that over here and have it be 6x. What it means is that you also have 1x left here, so that ends up being 3x. Now for square root of 20x squared, there's 2x, so that means that it can go on the outside. And then for the 20, we simplify that into 4 times 5. And then we simplify that because 4 is the perfect square of 2. So that's 2 times 2. So we simplified that down to that. So it's 2x. And then there's a 5 left over, so that goes in the square root of 5. Now with the 108x cubed, same thing with the starting one. An x is allowed to go on the outside, right here. But there's still an x remaining. And then with the 108, we divided it by 2, which is 54 times 2. And then we simplified it even more, 27 times 2. There's 2 2's here. And since it's not cubed, it's only square, which means that you can have the 2 2's on the outside. And then we simplified 27 times 3 and 3 times 3 for 9, because 9 is perfect square of 3. So then we went down to 3 times 2, which is 6. And with the 3 left over, we had it over here. And then with these new simplified numbers, we realize that the first and the third are the same. 6x to the square root of 3x is the same as 6x to the square root of 3x. So therefore we added them, which resulted in 12x to the square root of 3. And then we used the final one that was left over, minus 2x to the square root of 5. That's the most you can simplify it. Now for question B, we have 4 minus the square root of 15 divided by 2 to the square root of 2 minus square root of 3. Now with here, since it's not just one denominator, you can't just take the square root of 3 and times it up here and down here. You have to use the whole denominator, and you have to make it positive since you're using 2 of them. So it's the square root of 2 plus the square root of 3. Now with the denominator, you just times square root of 2 times square root of 2 and square root of 3 times square root of 3. Since it's a negative and a positive, and they cancel out the middle area. So therefore, that's a square root of 4, which is the perfect square of 2, so that's 2. And square root of 3 is square root of 9, so that's 3. 2 minus 3, because it's still a negative, because even though it's a positive here, it does not change. It's still a negative back here. So it's 2 minus 3 equals negative 1. So there's the denominator figured out. And then for the top, we did square root of 2 times 4, square root of 3 times 4. That equals 4 to the square root of 2 plus 4 to the square root of 3. And then we did the square root of 15 times the square root of 2, which is square root of 30. And the square root of 3 times the square root of 15 equals square root of 45. Now these are all simplified down to the highest they can be. These ones cannot be simplified anymore. Square root of 45, though, can still be simplified. Simplify it down to 15 times 3. And the 15 is simplified down to 3 times 5. So therefore, there's 2 3's. So now that can bring the 3 to the outside. And the 5, since there's only one of them, remains on the inside. So therefore, its square root of 45 is now turned into 3 to the square root of 5. Then we plug in all these numbers down here. Replace the square root of 45 with this 3 to the square root of 5. And we divide it by negative 1. So that turns all these positive numbers into negative. So it gives your answer is negative 4 to the square root of 2 minus 4 to the square root of 3 minus square root of 30 minus 3 to the square root of 5. With 30, you could not simplify it anymore. You could have tried 15 times 2 or 3 times 10, but it wouldn't have given you two of the same numbers.